All right. Good morning. Actually, I'm not sure what time it is you're watching this, but I'm making it in the morning. So, good morning. Today, we're actually finishing up our cell cycle unit. This is Unit 6 here. Last bit of notes on that. So, watch this video. Kind of take your own notes. Finish the unit, and then there'll be just a quick homework after that when you get done with this. Excuse me, not 6, Unit 8. Losing my mind here. Unit 8.6. So there's a 6-part. Sorry about that. Man, using a bad eraser already. 8.6. Cancer. So an unfortunate topic, something we're unfortunately probably all too well aware of. And that's what we're working with today. So all right, so imagine a cell that's lost its control of its own ability to regulate going through the cell cycle. So we talked last week, we talked about the cyclins and the kinases and how they kind of turn the cell on and off, kind of drive the cell through the cell cycle. Well, what if a cell loses control of that? Most likely, this is due to a mistake in the DNA, or what we call mistakes in DNA are mutations. So more than likely, the reason why the cell has lost control of its ability to regulate itself in the cell cycle is due to a mutation. So when that cell grows and divides and copies its DNA, it's going to copy that mutation and it's going to pass that mutation on to its offspring. Here's an unhealthy cell. Let's say it has 2 chromosomes. So definitely, excuse me, sorry about that. Definitely not a human. It's got 2 chromosomes. And hey, there's that mutated chromosome. Mutated chromosome in red. Well, when he duplicates himself, he's now got 2 mutated chromosomes. When he divides, Again, bad news. Oops. And remember, when they divide, that X is going to come apart. We're no longer going to have that X. It's just going to be a single chromosome now. But each of the two new daughter cells has that same mutation. That same red chromosome with the mistake on it. When these cells, again, they've lost the ability to regulate the cell cycle, just like the parent cell. They can no longer regulate the cell cycle, so they too will go through S phase. A little bit bigger. And they're going to duplicate the chromosomes. They have one healthy chromosome, but they're also going to make a copy of that mutated chromosome. And guess what? Now they're going to divide. Remember, they've lost the control to stop themselves from dividing. They can't turn themselves off. And before long, you're going to end up with a whole bunch of cells with this mutated chromosome. And none of those cells will have the ability to turn itself off. They're just going to continue to grow and divide and grow and divide and grow and divide and pass on that mutated DNA. So it won't be long. You guys can, you can do the math. 4 is next become 8, and 8 will become 16. And before long, you've got hundreds of cells, and then eventually thousands, and then eventually millions. When this happens, this new colony of mutated cells, so here we have this new colony of mutated cells, and again, it's going to continue to grow. It's it's still going, still getting bigger. Make sure you guys can see if those are red. It's going to continue to grow, continue to get bigger. This is what's called a tumor. So if you've ever heard of a tumor, well, that's what it is. It's just this collection of cells that kind of all have the same mistake, and largely they can't stop dividing. They just keep getting bigger, larger, growing. And again, that's a tumor. Right, there is a little bit of a distinction between biology. That's what we're in right now. Biology and medicine. In the biological sense, we call this new growth, we call this colony of cells with the same mistake, we call that cancer in biology. Medicine doesn't call it a cancer yet. We'll talk about it in just a minute here when medicine reaches the point of calling it cancer. But again, according to biology, technically these are moles. If you've ever seen moles, you probably even have one or two yourself. And generally, moles are not particularly harmful. Doctors oftentimes advise you to take a look at them, kind of watch them, make sure they're not getting bigger. And there's a whole bunch of steps you should take to regulate that. But moles oftentimes are a group of skin cells that have a mutated DNA. That's why they're a little bit different color than the rest of your skin. So they have a little bit different color, sometimes have a little different texture because they've got these mutations. And so all the cells that they proliferate into also have those mutations. A lot of times tumors like these are not growing out of control. Again, they're limited by resources. Even if these guys continue to grow and divide and continue to grow and divide and continue to grow and divide, they can't go forever because they're going to run out of room or they'll run out of resources. So there are ways cancer cells can get around that, but not all cancer cells in the biological sense are necessarily dangerous. So again, technically, according to biology, moles are cancer cells because that's what's happened with moles. So if that tumor stays in one place, it's known as benign tumor. So your moles, they generally are not spreading to other parts of your body. They're just localized to the one place that you have them. They are benign tumors. Usually, if you would like, these can be removed surgically. So doctors can go in and then just kind of cut out your benign tumor. I'm not saying they always do that. They usually say, hey, if it's not bothering you, if it's not causing discomfort, if we don't notice that it's growing and getting worse, if there isn't, evidence that it may spread, it's just kind of staying where it is, it's not harming yet, why go through surgery? So a lot of times they'll just leave benign tumors, but if you really want to remove it, or if it's causing you discomfort, or if it has a potential to get worse, we can usually surgically remove benign tumors. Go in and kind of cut them out. So other times, tumors can detach, or cells of a tumor can detach and enter your bloodstream and travel to other parts of the body. And that's going to be a lot worse than your benign tumors. We'll give that a term in just a second here. I'm going to flip the page before we do so. So give you guys 1 second to get that copied down. And I wanted to add some background sound also. So if it's too distracting, let me know. So this process is called metastasis. When a cell is able to break off of the tumor, get into the bloodstream and travel, that's called metastasis. So we'll call this our tumor cells, put a little X on them. They're mutated, they're growing out of control. And again, what can happen? Got a blood vessel here. And what can happen is cells can break off from the tumor, get into the blood system, and they're sometimes able to travel through the blood system to other parts of the body, where they then exit the blood system, or potentially can exit the blood system, and then they can start another colony or another tumor there in the different part of the body. And you can have your different cancer cells traveling and moving to different parts of the body. And again, this process here, this is called metastasis. When those cells are spreading, moving to other parts, this is metastasis. So we say a cell has metastasized, or a cancer cell has metastasized when it is starting to move and create tumors in new parts of the body. Okay, once tumors have metastasized, once they're starting to spread throughout an individual's body, now we call them a malignant tumor. So mal is bad in Latin, so these are the bad tumors. And these are now considered cancer in the medical sense. So before, a benign tumor generally is not considered cancer in the medical sense. Biological sense, yes, it's a mistake in a cell, and that cell is proliferating and passing that mistake on. That's cancer. In the medical sense, we really term medical sense cancer as to once it starts to spread, once it starts to metastasize. So what you're listening to now in the background, there's rain. Not sure how this is showing up. Again, I'm going to ask for your guys' thoughts on that. So if it's not good, let me know. Let's try this one real quick. So you guys think about this background music. So in the medical sense, a malignant tumor is much, much more difficult to deal with. We can and oftentimes will go in and surgically remove the tumor, but if it's already started to spread, it can be tough to make sure you get all of its additional colonies. The doctor might be able to go in there and say, I'm going to take out this lump and that lump and another lump. But what if they missed another small lump? What if there's still some of those cells in there? And so that's why a lot of times you hear of remission, people going into remission. Perhaps they're able to beat the initial cancer, but some cells survived. Maybe we didn't see them. Maybe they weren't quite ready to make a big lump yet, and then they come back, they remiss. So other treatments, in addition to potentially having surgery, is high energy radiation. So we're shining UV lights or radiation lights, X-rays and such, at the tumor cells, and chemotherapy, which are basically really toxic drugs. They're deadly drugs that kill cells. Both treatments are pretty awful, I would think. Again, they're designed to kill cells. Our hope is that by taking these toxic drugs or by targeting the high energy radiation, the hope is that we're able to kill the mutated cells. And although you might kill some of your own cells, well, your own cells can eventually come back. Your normal healthy cells can come back. So hopefully if we eliminate the tumor, even if you have a rough period of life by taking these drugs, someday you can recover and those cells won't be there. Sorry, not sure what I was trying to spell there. Chemotherapy, I'm guessing you guys have heard of it. Chemotherapy drugs, as well as the high energy radiation, they oftentimes target fast growing cells. That's oftentimes what cancer cells are, cells that divide and grow very quickly. That's why a lot of times cancer patients' hair will fall out, because those are fast growing cells. They're not the target cell. Target cell is the cancer cell, but they are adversely affected by the same drugs. So those drugs are going after fast dividing cells. Interesting enough, I know a lot of cancer drugs actually target the microtubules. So you think about, again, we're working with the cell cycle right now, and you think about metaphase and anaphase, when those microtubules connect to the chromosomes and then pull them apart during metaphase and anaphase. Well, I know a lot of cancer drugs actually target the formation of microtubules in a hope to stop those cells from being able to divide. Again, they can't divide, they can't go through mitosis if they can't pull those chromosomes apart. So an interesting approach and very relevant to what we're learning about right now. So as we just mentioned, both those treatments are targeting cells that grow and divide quickly, because largely that's what cancer cells are. They're growing and dividing out of control too quickly. All right, one last note for today. All right, so we just talked about cancer. When cells lose the ability to regulate their own cell cycle, often due to a mistake in the DNA. Bad things happen, and cancer is generally not a good thing. So when a healthy cell recognizes that it is losing or has lost its ability to control its own cell cycle, it's going to go through apoptosis. Talk about what that is in just a second here. Usually, cells recognize that they're out of control, they've lost control, that they have that mistake, they have that mutation. They're usually going to notice that during that G2 checkpoint. And that's the checkpoint at the end of G2 before we go into mitosis. The DNA has already been copied, and the cell double checks to make sure that it copied all its DNA and copied it all correctly. So apoptosis is programmed cell death. The cell basically kills itself if it realizes that its DNA is growing out of control or is mutated and may lead to the cell growing out of control. Again, it seems harsh, but if it copies itself and it copies its DNA, it's got these mistakes, the outcome is the end outcome, the other outcome is going to be a lot worse. So programmed cell death, what happens? So going back to first semester a little bit, we talked about lysosomes. One of the organelles our cells have is lysosomes. And lysosomes are just little vesicles, so membrane enclosed bubble basically. And inside of that membrane enclosed bubble are hydrolytic enzymes. These are enzymes that break biological molecules down. So when you have worn out old organelles, lysosomes break them down, recycle them. Usually you only have one, or well, you have several lysosomes, but usually you kind of keep all those enzymes inside the lysosome. Those are, they're like little piranhas. They're going to chew everything up. So usually we just keep the hydrolytic enzymes inside the lysosome, and that way they don't eat the entire cell. They just eat what the lysosome goes to, which might be a broken down organelle that we want to recycle. In apoptosis, what happens is the cell signals all of its lysosomes all at the same time to just go ahead and release those hydrolytic enzymes, and they do, and then the cell basically just eats itself from the inside out. Kind of a gruesome thought, but again, a lot better than the alternative. All right, so that finishes up Unit 8. When I see you guys again on Tuesday, we're going to start our next unit, Unit 9. So take a look. There's a very quick homework, so take a look at that. And I'll see you guys next week.